everyone, welcome to our next lesson, the real number system. Okay, let us first have these following terminologies used to clarify number sets and their notations. First, we have here capital letter N, which is the set of natural or counting numbers or your positive integers. So, kailan na kay taani nga mga numbers? 1, 2, 3, 4, 5, 6, 7, and so on. So, these are your positive integers, or what you call our natural or counting numbers. Next, we have capital letter W, which is the set of whole numbers or non-negative integers. So, ang atong whole numbers are your positive integers and 0. Next, we have here capital letter Z, which is the set of integers. When we say integers, naana din ang imuhang positive numbers and your negative numbers with 0. Next, we have the capital letter Q. This is the set of rational numbers. Ang atong rational numbers, we have this A over B such that A and B are elements of the integers, but B is not equal to 0. So, ang rational numbers na to, mao to atong mga fractions. Ang atong fractions nga element ang A ug B sa integers, pero dili dapat 0 ang denominator. Since kung 0 ang denominator, undefined na siya. Okay, so ang rational numbers na to, mo to atong mga fractions. Another, we have the complement of Q. This is the set of irrational numbers. This is X such that X is not an element of Q. So, ang ato ang irrational, katong dili mga rational. Unsa man tong example sa atong irrational numbers? So, we have square root of 2, your pi. Those are non-repeating and non-terminating numbers, meaning dili balik-balik o dili maputol. Example, katong pi. Diba pi is equal to 3.1416 and so on. Daghan pa to siya sumpay. So, dili nagbalik-balik ang numbers, wala po siya naputol. So, maunay mga irrational numbers. Next, we have the capital letter R. This is your real numbers. So, this is the union of your rational and irrational numbers. So, kung isagol nimo ang rational ug irrational, mauna na sila ang real numbers. Last, we have capital letter C, which is the set of complex numbers. This is equal to A plus BI, where A and B are elements of the real number, and I is equal to the square root of negative 1. Okay, remember your I, this is the imaginary number. That is square root of negative 1. Okay, so now we have this diagram sa atong complex numbers. Under the complex numbers, we have the imaginary numbers. Kana siya with the pure imaginary and the real number system. So under the real number system are the irrational and the rational numbers. So under sa imong rational, you have your integers. Under your integers, you have your whole numbers. And we have the natural or the counting numbers. So, mao ni siya ang ato ang mga numbers nga nahibaw-an. We have here the set of natural numbers N and the set of integers Z. Let us read the following remarks. The sum and the product of two natural numbers is again a natural number. When we say sum, mao ni siya ang resulta when we add. Kung mayroon tag product, this is the result when we multiply. So, kung mag-add o mag-multiply ta og two natural numbers, ang result is a natural number pod. Next, The difference of two natural numbers is not always a natural number. So, difference mo ni siya ang resulta kung mag-subtract ta. Kung mag-subtract ko no tag two natural numbers, dili sa tanang panahon natural number ang mugawas. Kay pwede man ta na ay negatives. Next, the sum, product, and difference of two integers is always an integer. So when we add, multiply, and subtract two integers, ang resulta is always integer. Then last, the division of two integers is not always an integer. So when we divide two integers, dili sa tanang panahon, integer pod ang resulta. Let A and B be integers. We say A divides B if there exists an integer C, which is an element of the integers, such that B is equal to A times C. In symbols, we write A divides B if and only if B is equal to A times C for some C, which is an element of integers. Next, if A divides B, we say B is divisible by A, and A and C are divisors or factors of B. We also say B is a multiple of A and of C. If A does not divide B, we write A does not divide B. So, ang ato ang pasabot sa A divides B, meaning, pwede ma-divide si B ni A. Then, if we have C, which is also an element of integer, ang ato ang A ug C, mo na siya ang factors sa ato ang B. We call that factors or divisors of B. Example, we have 6 is equal to 3 times 2. So, 3 and 2 are factors or divisors of 6. Mauna ni siya ang example number 1. 3 divides 6 since 6 is equal to 3 times 2 and 2 is an element of an integer. Another example, 4 divides 6 since there is no C, which is an element of integer, such that 6 is equal to 4 times C. Then, next example, 1 divides n for every n is an element of integers since n is equal to 1 times n. Okay, next, let us define prime and composite numbers. So, a counting number n greater than 1 is a prime if its only divisors are 1 and n. So, prime numbers tawag pag ang divisors na to 1 and itself lang. So, examples of prime numbers less than 20 are this: 2, 3, 5, 7, 11, 13, 17, and 19. So, ang 2, diba, ang iyang factors 1 and itself lang. Ang 3 pod 1 and 1 times 3. 5, 1 times 5. So, kani sila, ang only factors nila kay 1 and itself. Next, any counting number n greater than 1 that is not a prime is called composite. Composite numbers have factors other than 1 or themselves. So, katong dili mga prime, tawag na to sila composite numbers, meaning they have factors dili lang 1 and itself. Like these numbers, 4. Ang 4 pwede 2 times 2. Ang 6 pwede 3 times 2. 8 pwede 4 times 2. 9 pwede 3 times 3. So, these numbers are composite numbers. Basta ang iyang factors, dili lang 1 and itself, daghan siya pala in factors. Okay, we have the next theorem, the division algorithm. Let A and B be element of integers, and B is greater than 0. Then, there exist integers Q and R such that A is equal to B times Q plus R, which is R is greater than or equal to 0 or less than B. where Q is called the quotient and R is the remainder. So, example, we have here A is equal to 11 and B is equal to 4. Then, we can have this 11 minus 4 times 2 plus 3, where 3 is greater than 0 but less than 4. So, here Q is 2 and R is 3. So, di ba ang atong Q is the quotient? Quotient meaning ang resulta when we divide two numbers. Then, R is the remainder. So, kung moingon tag 11 divided by 4, so the result is 2 remainder 3. Okay, another, if A is equal to negative 11 and B is equal to 4, then negative 11 is equal to 4 times negative 3 plus 1, where 1 is greater than 0 but less than 4. So here, your quotient is negative 3 and your remainder is 1. So when we say negative 11 divided by 4, the answer would be negative 3, remainder 1. Okay, next we have the unique factorization theorem. A natural number greater than 1 can be written as a product of primes in a unique way except for the order of the factors. Prime factorization is the process of finding the prime factors of a composite number. Examples. Find the prime factorization of the following. So here's how we find the prime factorization. Okay, example number 1 is 12. So, ang 12, ato lang siyang pangitaan o factors nga puros prime numbers. So, 12 can be 2 times 6. 2 is a prime number, but 6 is not. Dili pa siya prime number. So, ang 6 pangitaan na pud na tog factors nga puros prime. So, 6 is 2 times 3. So, the prime factorization of 12 is 2 times 2 times 3. Next, we have 224. So, 224 can be 2 times 112. 112 can be 2 times 56. 56 can be 2 times 28. 28 can be 2 times 14. And 14 can be 2 times 7. So, diri, puros nata prime numbers. So, ang 224, mao ni siyang ato ang prime factorization. We have 2 times 2 times 2 times 2 times 2 times 7. Last, we have 240. So, 240, pwede ang factors niya 2 times 120. 120 can be 2 times 60. And 60 can have factors 2 times 30. And thirdly, pwede po siya 2 times 15. And 15 is 3 times 5. So, 240 is equal to 2 times 2 times 2 times 2 times 3 times 5. So, inanaon ang prime factorization. We find the prime factors of the composite numbers. Okay, let us have some definitions. D is a common factor or divisor of two natural numbers A and B if and only if D divides A and D divides B. So, tawag na to common factor si D sa duha ka natural number nga A ug B. Kung ang D pwede ma-divide ni A, pwede po siya ma-divide ni B. So, tawag ana common factor. Okay, the greatest common factor denoted by GCF of two natural numbers A and B is the largest natural number, which is a factor of both A and B. So, ang greatest common factor maoy kinadak-an nga natural number nga factor ni A og ni B. Then, the natural numbers A and B are relatively prime or co-prime if GCF or A, B is equal to 1. So, co-prime sila kung ang ilang GCF is 1. Okay, next. M is the common multiple of two natural numbers A and B if M is a multiple of A and M is a multiple of B. So, common multiple si M, kung multiple siya ni A, multiple po siya ni B. And we have the least common multiple denoted by LCM of A and B is the smallest natural number for which A and B are factors. So, ang LCM ay pinakagamay nga common nila nga multiple ni A o ni B. So, kung mo yung tag-multiple, panalitan. 6 is equal to 3 times 2. Ang 3 and 2 are the factors. Ang 6 mo to siya ang gitawag na to nga multiple. So, LCM kinagamian nga pareha nga multiple sa ato ang duha ka factors. So, example, let us find the GCF and LCM of the following. We have 10 and 30. So, in finding the GCF, inanion lang siya. 10 is equal to 2 times 5, diba? 30 is equal to 2 times 3 times 5. Muna siya ang atong prime factors. Factorization sa 30. So, in finding the GCF, ato lang i-bring down ang common nga factors. So, ang 10 na siya 2, si 30 na apoy 2. So, bring down ang 2. Ang 10 na siya factor nga 5, ang 30 na apoy 5. So, bring down ang 5. So, ang GCF, i-multiply lang nato ning duha. 2 times 5 is equal to 10. So, the GCF of 10 and 30 is 10. How about the LCM? How to find the LCM? So, ang common na to nga factors 2, gi-bring down, apilon ang nahabilin. Bisan, wala siya'y kapariha sa 10. I-bring down gihapon. Then, ang atong common, i-bring down. So, ang LCM na to is 2 times 3 times 5. That is equal to 30. So, the LCM of 10 and 30 is 30. Next example, we have 224 and 240. Ang atong 224, atong i-prime factorization. So, we have 2 times 2 times 2 times 2 times 2 times 7. So, mao ni siya ang prime factorization sa atong 224. Then, 240 pod, ang iyang prime factorization kay 2 times 2 times 2 times 2 times 3 times 5. So, again, in finding the GCF, i-bring down na to ang common. Kana. So, dere, dili na wala na naman na siya common. So, ang common lang. So, 2 times 2 times 2 times 2 is 16. So, the GCF of 224 and 240 is 16. Now, in finding the LCM, atong i-bring down ang mga common and then ang mga sobra atong i-appeal. So, 2 times 2 times 2 times 2 times 2 times 3 times 5 times 7, that is equal to 3,360. So, that is how you find the LCM. So, the LCM of 224 and 240 is 3,360. Okay, let's move to the set of rational numbers or your Q. Q is closed under division except by 0, addition, subtraction, and multiplication. We have here forms of rational numbers Q. First, we have the fraction forms or the fractions. Under the fractions, we have two classifications, the proper and improper fractions. So, in improper fractions, these are the examples. 2/3, 3 over 10, 12 over 13. So observe that the numerators are less than our denominators. So mas gamay ang mga values sa numerator kaysa denominators na to. So pag inana, tawag ana niya proper fractions. Sa improper pod, these are the examples. We have 3 halves. This is a mixed number, 1 and 3 over 10. Or that is 13 over 10. And we have 12 over 12, then 15 over 4. So observe that ang ato ang numerators are greater than or equal sa ato ang denominators. So ang ato ang mixed number, pag himuon nato ni siyang fraction, this is 10 times 1 is 10 plus 3. This is 13 over 10. So, ang iyang numerator na is 13, which is greater than sa iyahang denominator. So, pwede po same ang numerator o denominator. That is also an improper fraction. Okay, moving on, we have the decimal forms. We have the terminating decimal and repeating decimal. Okay, these are examples of your terminating decimal. 1.2000, 0.2, 1.3540000. Then your repeating decimal. Ang repeating katong magbalik-balik ang iyahang decimal nga digit. Like this, 1.33333 and so on. Or you can write this as 1.3 bar. Meaning anang naka-bar, meaning ang kana nga number nagbalik-balik. Then dili maputol. Also, we have 0.234, 234, 234. So, mo nang naka-bar si 234. 0.234 bar. Meaning, nagbalik-balik na si 234. Then, last, we have 2.345545. So, that can be written as 2.3. Naka-bar si 4 and 5. Since, ang 4 and 5 raman ang nagbalik-balik. So, these are your set of rational numbers. Another two rational numbers A over B and C over D, where B is not 0 and D is not 0 are equal. That is A over B is equal to C over D if and only if A times D is equal to B times C. So, dapat dili zeros atong denominator like I've said, undefined na, dili na siya pwede. So, sa atong example, 4 over 8 is equal to 1/2. Since 4 times 2 is equal to 8 times 1. So, 8 is equal to 8. So, mo na siya cross multiply. 4 and 2, 1 is 4 times 2. Then 8 times 1, na siya. Okay, changing a fraction to decimal form. The decimal form of a rational number is obtained from its fractional form by the usual process of division. Example, how to change fraction to decimal. Okay, use long division to write the following rational numbers as decimals. Tell whether the decimal expansion is terminating or repeating decimal. So, number 1, 2/5, that is equal to 0.4. Yun sa nato pag ka-arrive nga 2/5 is 0.4 di ay. So, ang ato ang numerator 2 divided by the denominator nga 5. Sa ato amaning klase sa elementary tanaw. So, ang 2, dili man siya jud ma-divide og 5, so let us put there 0. Then, let us have 0, itapad na to sa 2. So, 2.0 na ni. So, kaning 20, pwede na ni siya ma-multiple sa 5 and 4. Since 4 times 5 is 20, so 20 minus 20 is 0. So, 2 divided by 5 is equal to 0.4. So, that is how we change a fraction to decimal. Another example is an improper fraction nga 22 over 3. Giyosa na to pagka-arrive ng 7.333 and so on. So, parihara gihapon 22 divided by 3. So, 22 divided by 3 is 7. So, we write 7 sa taas. Then, 22 minus 21. Di samantaning 21. 7 times 3. Diba? 21 ra siya. Naatay na habilin nga 1. So, bring down tag 0. So, unsa na po ang ato ang ma-multiply sa 3 nga makaabot tag 10. So, 3 times 3, 9. So, 10 minus 9 is 1. Then, bring down na po 0. So, ang kani siya, balik-balik na ni siya nga process. Diri maoning 7.3333 and so on ta. So, easy ra na siya. Ato nang nagian sa atong elementary. So, that is how we change a fraction to decimal. Okay, next, changing decimal to fraction na pod ta. So, terminating decimal, multiply the number by 10 to the power of n over 10 to the power of n, where n is the number of decimal places. So, example, find the fractional form of the following terminating decimal. Okay, we have here 1.2. So, in fraction, 6 over 5. Ganong 6 over 5 man natong fraction, yun sa nato. So, inani. Ang 1.2, pila man ang iyang decimal, di ba? Isa lang. 0.2, isa ra si 2. Ato na siyang i-multiplyan o 10 to the power of 1 over 10 to the power of 1. 1 ni siya kay ang 2, isa ra man na siya. So, the result would be 1.2 times 10 is 12 over 10. Then, 12, ang factors ni 12, prime factorization can be 2 times 2 times 3. 10 also can be 2 times 5. So, cancel ta sa ibabaw. Ang mga bilin is 6 over 5. Another, we have 0.234. Pila man ka decimals ang 0.234 tulo. So, that is why we multiply it 10 to the power of 3 over 10 to the power of 3. So, 0.234 times 10 to the power of 3, that is 234. Move ramang kadihaan nag 3 decimal places. Mo ng 234 over 10 to the power of 3 is 1,000. So, kuan ato siyang lowest form. So, ato ang kuan og factors, prime factors, para ma-lowest form na to, para natay makancel. So, maaning 2 times 117, maaning si 234. Then, 1,000 can be 2 times 500. So, we cancel it. So, the result is 117 over 500. So, that is how you write a decimal into fraction. Next, we have writing, repeating decimal into fraction. So, these are the steps to follow. First, represent the decimal number as x. Second, multiply the equation by 10 to the power of n, where n is the number of decimal places before the repeating block of digits. When n is equal to 0, this step yields the same equation in step 1. Third, multiply the result of step 2 by 10 to the power of m, where m is the number of digits in the repeating block. Note, steps 2 and 3 result in two equations involving numbers whose decimal parts are the repeating digits. Fourth, subtract the equations obtained in step 2 and 3. And last, solve the equation obtained in step 4 for x. So, this is how we write repeating decimal into fraction. So, example, nata diri 0.83, ang 3 naka-bar. So, meaning ang 3 mo ay nag-repeating. So, first step is to let x be your decimal number. So let x is equal to 0.83 bar.